Hello everyone, welcome to a very special live stream. This is the first time we're doing this format, and it's about time that we start talking much more about what we build, how we build it, and why we do it the way we do it. It's a special occasion because for the first time we have our dear CTO Kamran with me today here, presenting to all of you how we are going about scaling peaq and what is implied in that, because scaling systems, scaling blockchains is a huge topic. And on the surface, you always just see it has a lot of TPS and it has low block time, but you don't really, most people don't go underneath and look inside the car and look at the engine, right? Because scaling is not equal scaling. And this is what we're going to cover today. And we're going to also have a wonderful demo for all of you to show how the testnet is scaling. And this will be released also mainnet at a later point. But without talking much longer on the introduction, because we have very interesting topics to cover today, I'd love to start right away, Cameron, by asking you, because you have vast experience. You've been in Web 1, you've been in Web 2, now you're in Web 3, right? To give us a bit of an introduction on your experience in Web 2, especially when it comes to scaling systems. You've told me a story when we met at the office the other day, and that really, I was surprised how many parallels there are between Web 2 and Web 3 scaling. And still many people don't seem to see them as clearly as you do because of the experience you have. So yeah, please give us an introduction to your background in Web 2 and the scaling issues you faced back then.
Thanks a lot, Leo. It's an absolute pleasure, I would say, to be here, building peaq, making it sure that the network is scalable for many decades, for about like we have been building for many years, behind the curtains and now coming in front of the curtains. I think I'm very pleased and I'm very happy, plus excited also, right? So yeah, without wasting any time, right? Like though, as Leo mentioned, have an experience in Web 1, Web 2, Web 3. I may sound old, but I'm not that old, right? Uh, so yeah, like going back into the days, right? Where I was privileged to see the transition from Web 1 to Web 2 to Web 2 to Web 3 and the disruption of businesses, right? I used to work in a telco, right, that was pivoting away from the traditional telco business to mobile financial services, right? And there was a huge spike in the traffic, right, when it comes from customers as the banking services starts including the mobile money, the mobile usage got increased, right? Like there was a huge spike in the usage of softwares, right? And there was only one method that we used to know and to build was like having a frontier and a front interface and a back end, right? Like running on one machine, right? And as Leo
This
said,
is this is called
yeah,
monolithic architecture, right?
yeah,
Just to,
yeah,
yeah.
yeah, like one tier architecture, monolithic architectures, right? Like we only knew this is the way to build the software, right? And as Leo mentioned, right, like I poor development guy working on systems, and it came out to be a situation where I have to manage the traffic of about 18 million users, right? And I build the application the same way I used to build, like a front end, back end on a front end and a back end, right? A database putting on one machine, monolithic architecture, simple. And it turned out that the software used to crash every morning when there was load on the system, right? And I was being bashed left and right from my own CTO, right? Like that, put more hardware onto the machines, put more hardware onto the machine. And trust me, I put all the infrastructure that was available um, on the data warehouse, but it never worked, right? Like it never worked. So that led to the point that we realized that no, it's not just putting the bare metal, it's the architecture that matters, right? How softwares are built.
Exactly.
And
And just
today,
just
yep.
sorry for interrupting there, but I just want to make that parallel, right? Like we hear, so your CTO came to you and said, Cameron, just put more hardware. Like just put more resources at it and it will work. Why is the architecture crashing? And we hear that in the Web3 space as well, right? Like there are protocols, there are networks which are just all about better hardware, faster hardware. Um, but eventually you hit a wall, right? In Web2, 18 million users, and there was just no way to solve the problem anymore, putting more hardware. And yeah,
Absolutely. Absolutely, Leo. As you mentioned, right? Putting resources doesn't solve the problem, right? Like you can, there's a limit to everything, right? Like you can scale up the server as much as you can, but if the engine, the software is not designed in a way to take that load, that will never work. And there are many parallels, as you said, in Web 2 and Web 3. You can say many protocols, many network, many layers that are just reliant on the hardware. They sooner or later they will hit the wall as it was hit in Web 2. That led to the design principles of changing how softwares are built, the mentality that okay, putting resources will never work. There's something else to that.
exactly. There's something else to that. And yeah, so what happened then in Web 2? Like how did you, I think one day you actually said, hey, stop, no, not more hardware. We're gonna change the architecture, right? And you got a team where you and that team had the job to change the architecture for 6 months or something like this. I think it was a crazy sprint. But what did you do there in that
Yeah.
process?
As like getting bashed every morning, spending nights, putting servers, acquiring machines, that led us to be burnout for within a couple of days and or week, right? And then we hit the wall, as you said, right? And then I took the stand and I said that, guys, look, if we need to scale this up, we have to come up with a different methodology, a different way of how things are built. And that was the point where we moved from this monolithic one tier architecture to multiple tier architectures, right? Or we can call it a service oriented architecture, the concept of microservices, where each service has an independent function. And this is not on the hardware level, this is on the software level. So when you have every service, every function that has a job to do, if it is independently built, you can scale it better.
Exactly. So
And
it's just maybe to
yeah,
summarize for the viewers as well. So monolithic was really you have a database and you have a front end, right? And the front end and the database are directly connecting, and the front end is writing into the database. And now the service-oriented architecture, which Cameron was talking about, added a layer in between. You have the front end, you have the database, and you have the traditional, like the back end as we know it today, where you have many different back end services which all do different jobs, right? And they can work in parallel. So you can scale it horizontally, correct, Cameron? Right? Before it was vertical. And now you suddenly have that layer where you need the backend service, I don't know, 10 times. You just have it 10 times and it can work in parallel, right? And that allows the backend to be upgradable and scalable. And any modern web application is running on that system. I think WordPress was also a classical monolithical system, right? So anyone who built something with WordPress and had scaling issues, I think that's the reason. I talked to my cousin the other day. He built a web platform with WordPress initially, and he said, "Yeah, I know the pain. I understand this." Um, yeah. So and this is basically what you've implemented, right? Like a modern architecture, and this solved the problem, correct?
yeah, like well, absolutely, Leo, you're spot on, right? Like it can be as simple as it gets, right? Like you have to separate the needs. You have to separate the needs of the software that you are building, right? One is payments, one is signing in, one is having searching, right? If they are separately built, you can scale them very easily as compared to if you put them all in one box, or RBCAS at one tier architecture or monolithic architecture, then you have to scale up the box as compared to scaling up smaller pieces. It's as simple as that. It gets, and it took us a lot of time. If you go back in the history, you will hear a lot of people complaining about databases issues. We cannot scale up logs. resource management, a lot of hardware metal being put. But the solution was never to have an excellent hardware or a super hardware to solve it. It resided in how software are designed and built, and that is how it is done.
And I think just adding there, because that came to mind right now, it's slightly off topic, but if you think about if you make scaling of a system dependent on hardware, it will naturally always gravitate more towards centralization because you need to optimize the hardware. And if you optimize the hardware in Web3, you have either a centralized sequencer, many layer 2s have this, one machine literally taking care of block production and execution, or you have chains that are high performance, which are monolithic, but then you have very big hardware requirements, and the network also gravitates towards centralization. We know this. There are like all the monolithic chains which are high performance have exactly this problem. So, but if you solve the scaling problem on a software level, right, and you build a microservices like architecture, you can actually achieve very high performance while maintaining high decentralization, because every node which is less performant can do something in parallel, and the scaling is done on an architecture level or not on a brute force hardware level. And yeah, so Cameron, I don't know if you have something to add there, but that just came to mind.
Now, absolutely right. When I see back on this path, right, and then I see the patterns. I think that this particular software design were meant for a decentralized architecture. It was never meant for a centralized architecture. If you go back, many normal users, many normal entrepreneurs, many small startups don't have enough money to put so much hardware, right? It was beautifully done for the decentralized world, and now as the stage is set, right? Like when you have that software architecture, then you have that software principles in place. This is a perfect place where we put blockchain onto these principle. And if we go back in the days where we used to have hardware like uh, hardware resources adding for improving the quality of the software, we are stuck in the same loop. As you said, that many chains currently are stuck in that loop.
Exactly. And before we go into the demonstration, which we have prepared on the testnet and which you will see for yourself, you will be able to check out the blockchain explorer, the transactions, you will see the dashboard and everything. It will be published on it will be published um, right as we finish this basically. And yeah, so before we go into this, we just talked about monolithic architectures on blockchains. Just a brief introduction. So, a monolithic architecture means in a blockchain that just everything that's necessary for producing a block is put together, just like a front end and a database was put together, and then you have this one massive beast, and this one massive beast can only be scaled with massive beast hardware. That's it, right? That's how it works basically. And now, if you have a more loose architecture, loosely defined, loose runtime, right, where you can actually upgrade the runtime, you can have a microservices like chain where, right, the backend of the blockchain basically gets scaled with microservices where constantly software updates can be made on runtime, like forkless runtime upgrades can be made that are basically adding new microservices to the blockchain network. Just as a analogy, it's not right. Just talking a bit more to make it easier to understand, and and suddenly you can scale a chain on a complete different level, right, Cameron? I don't know if you want to something to add there, but
Yeah,
would you
like
compare what you experience in Web 2 with what's happening now and what we've implemented on Peak?
yeah, absolutely. Like Leo, I think that I will just flip the term. That's loosely coupled architecture, right? We used to use this term a lot in Web 2, and that's a parallel now in Web 3 as well, right? Um, you have a node layer which is actually responsible for handling uh, networking, consensus, storage, and then you have a runtime logical layer where you have business rules, where you have state changes defined, right? If you put all this together in one package, right, in one layer, then if there is something wrong on the network layer, the runtime layer also suffers. Or if something goes wrong on the runtime layer, the network layer suffers. Or if there is a scaling issue on the consensus layer, the runtime layer also needs to be upgraded. Or if there is there's a performance upgradation on the runtime layer, the consensus layer or the node has to upgrade as well. It's a picture perfect example of what we used to have in Web 2, as I defined one package where we used to put a front end, a back end together and try to scale it. It's similar, it's absolutely a mirror to that where we are trying to put the node and the runtime logic in one piece and trying to upgrade it. It's not gonna work. It's the time
Yeah,
that we hit the wall again.
exactly. And it's interesting that some of the, let's say, more prominent protocols in the industry are using exactly that architecture. And I don't know if they are aware of it. I don't know if the industry or most people are aware of it. I mean, when you told me about your experience back then in Web 2, I was just like, it's obvious, it makes so much sense, and you see the parallels in Web 3, yet not many people seem to be talking about this yet. Yeah, so hopefully this this live stream will also educate people. And Cameron said in the introduction, we're always thinking decades ahead, right? We're thinking about, okay, which architecture decisions do we make, right? And which choices also of technology and stack do we make right now? That makes sure that peak in 10, 20, 30 years is thriving, right? And that's what I meant in the beginning. Scaling is not equal scaling. Two chains might have the same TPS or block time, but what's happening under the hood is different, and one chain can scale literally much further because the scaling is done with a good architecture or great architecture, and the other chain can't scale much further because it's scaling based on hardware and it relies on hardware improvements, networking improvements. And as Cameron just said before, these things, these monolithic architectures, they break down much easier. And we've seen this also in Web3. Yeah. Yeah. So I think it's time that we get into our actual demonstration. 1 second. Let me share the screen. Amazing. Cool. So, Cameron, um, you start
Yeah,
already firing transactions, right?
yeah,
We can see this
uh,
here.
yeah. So I will briefly go through this dashboard. So what we have done is that we have, as I explained us, we have decoupled the node from the runtime logic, right? And what we have done is we have demonstrated that okay, 12 cores are there, and you will see that as the need grows, you can see another core has been added. Uh, the traffic comes up, noded as is for the validator, right? Um, and in this way, we
A
can achieve
core, right? A core is
a
added.
core.
Yeah, yeah,
Yeah,
yeah.
a core is added, right? In this way, what we are trying to achieve here is that we are not adding, there's not a person who is adding a physical hardware into this thing, right? It's the beauty of the architecture that is designed that on the go with one click you can add a core, right? And you can manage the traffic because it is built in a way that it's not monolithic. It's basically a loosely coupled architecture where you can on the go manage your traffics, right? For example, a huge event comes up and you want extreme TPS for that, right? You can fire a couple of functions, a couple of commands, and you can add the nodes on the go. That's what we call as elastic scaling, right? That is what we are building, and we have been trying this for many years now, and you can see the results right here. Another core gets added, you can see the block time gets lower and the TPS start increasing. You can go, you can check it for your own self. I think Leo, you will be dropping the link to the interface. You can go on the Blockchain Explorer and you can see yourself that
Yeah.
it's happening in real.
Absolutely. And at this point, just want to give a quick shout out to the Parity team and Gavin Wood and the people at Parity, right, who are really understanding how Web2 scaling works and now how Web3 scaling works, right? And we're closely working on that and collaborating. And this is yeah, as Cameron just said, like the beauty here and cores themselves are a concept that comes from computing, correct? Where you have a CPU and you have a GPU. I think we discussed that it's not fully accurate, but if you think about a bit more of a monolithic architecture and design, it's closer to a CPU where you have a central processing unit, right? That has like one stream of processing, and when you have a GPU, you have many cores, many more cores than a CPU has that are working in parallel, right? So you can really think of it as a computer. And I mean, a blockchain is nothing else than a computer on the internet. And now with cores being able to produce blocks, in parallel, and you're able to scale up the amounts of cores that are used for block production. This is exactly mirroring I don't know if it's fully accurate, but what NVIDIA has done to computing, right? NVIDIA has created GPUs and completely revolutionized computing, because before computing just had CPUs. And yeah, this is, and how is that possible? I mean, as we talked about before, Cameron said this is really the service-oriented architecture, because is it accurate to say, Cameron, that each core is basically a microservice?
I would say so. It's as simple as that, right? And I think Leo, you were on bullseye. You hit the bullseye, right, by saying this the concept of asynchronous packing that we use, right? Like, okay, I have a block, I give it to a core, I took another block, I give it to another core, right? And on parallelly, the finalization is happening. You can see sometime it's block 817, it's 816, then it gets finalized, then 815. You don't have to wait. You don't have to wait. And I would repeat it again, right? The beauty comes from not adding the hardware. It's the architecture level thing, the software architecture that is there to be used. And if
That
you
is scale.
see,
Yeah.
yeah, if you see now we have hit block time 1 second, right? Right on the go, as we are seeing. There are no runtime upgrades being performed. There are no hard forks being applied. This is on the go that we are seeing this.
I think we're back. Yeah. I
Yeah,
don't, yeah, we're back. Yeah. So exactly there. So the TPS and the block time, like the transactions per second, are increasing just by adding more cores that are able to produce blocks in parallel. And as Cameron said, you see with the recent blocks, they are not they are not finalized in the same speed all the time, because they're finalized asynchronously, which means not synchronously. So okay, that's not a good way to explain it, but they are not finalized in one line, but in parallel. They don't, and so and now the block time jumped below 1 second. Why?
yeah,
Because, right, if you add a certain number of blocks, the block time is being reduced with each block, with each core being added, like
with
the
each
block
score.
time
Yeah,
gets reduced, right? Because the amount of throughput is increasing, and the speed of yeah,
yeah.
finalizing a
Like
block.
if you say now we have 8 cores added and the block time has gone below 1 second. That's really the beauty of the architecture that is there, right? You are just increasing the number of cores as you see the traffic starts flowing in. or I would say is that system is automatically scaling up to the needs of the traffic that's coming up, right? So you are getting very low latency, very less block time, a very high TPS right on the go. I would say there is nothing that you have to do hard forks. There are no people that I have behind in the data warehouse adding the bare metal, right?
Adding the bare metal.
Yeah,
Exactly. So we just really want to hammer home the point. You don't need better networking. You don't need better hardware. No, like that's narrative monolithic, trying to scale a monolithic system. You need better architecture. And you need a microservice like architecture and Web3 to scale a blockchain properly while making sure it stays decentralized and while making sure that, small validators with smaller hardware specs can also contribute. And yeah, like, I mean, Cameron and I, we are 100% certain this is the way to go. And we're also convinced that other architectures will run against the wall. I mean, they're already running against the wall, but it will just become more and more obvious as traffic, users, and things are spiking and increasing. And yeah, I mean, this is just in this demonstration, we're working with 12 cores, but it doesn't end at 12 cores, right? This can scale horizontally. And this is how peaq will achieve hundreds of thousands of transactions per second. And if we think about the machine economy or think about this global computer at some point, computing billions of machines interacting with each other economically, this thing needs to scale to very, very high TPS. And the architecture is in place, the foundation is in place. And yeah, we're very happy about being able to say with confidence, we're ready for the machine economy. peaq is ready for the machine economy.
yeah, absolutely, Leo. As you said, like you can add the hardware and you can see the results very quickly, but they are never long-lasting terms. I think for many years we have been discussing this, and I've been holding my ground that guys, we don't need to build for 1 year, 2 year. We don't build for hype. We are not here to add hardware and get push the TPS beyond the line. We need to work on the fundamentals. We need to have our fundamentals strong because when machine economy is hitting the ground, and it has already hit, there are millions and billions and trillions of machines coming. There are millions and billions of trillions of transactions happening. If our fundamentals are not strong, we are going to hit the wall very quickly. Don't rely on short-term gains by adding hardware. It will give you like 6 months, 8 months runway, but it will eventually fade away. It will eventually fade away. So it's all about having the fundamentals in place. And I think you and me have locked our horns very much in the past also, where I pushed that guys have the fundamentals in place, have the fundamentals in place. And now the time has come where we can see that the transaction sizes are increasing it tremendously, and the software is in place to actually handle that. And now we are about to go, I think, at zero point 0.5 seconds. We are already there. Yeah, leave.
Yeah, incredible. Exactly. We see the block times getting less and less. We see the peak TPS is getting higher and higher. We are now at 45K almost. And yeah, I just want to add to what you said. High TPS, low block time, these are prerequisites. At the same time, decentralization and censorship resistance are also fundamental prerequisites for us because we're building humanity scale infrastructure, and you need to be able to trust the system, because if real machines in the real world are acting and transacting on it, and billions of tokenized machine value, at some point trillions, will be stored on that ledger, right? You need to be able to trust it 100%, and you can only do that if the architecture used to build the system is actually one that supports decentralization and censorship resistance. We cannot have, I don't know, 20 data centers around the world running the chain, because no, like, we're living in times where, censorship is happening and will happen more and more. And we cannot allow peaq to, yeah, not be ready to defend against it. So yeah, wow, okay,
Yeah, I would
yeah,
say that we have hit 48,000 and we have achieved 5.5 seconds. That's a huge achievement, right?
yeah. We've just concluded the demonstration, and yeah, hit about 50K TPS there, half a second block time, and yeah, I just really want to emphasize this is the beginning because of the architecture that we talked about, right? It's microservices that we can scale up. We can scale up the cores that will increase the TPS further, reduce the block time further, right? So this is really like a scalable computer where you can just click a button, say one more core, one more core, one more core, and then it doesn't add more hardware. It just adds another core on the chain itself, right? And yeah, it's beautiful. I'm sure yeah, come on, wait.
Yeah, like we are rapidly working, massively working for its mainnet launch. It's on the testnet, Leo. Maybe you
Exactly.
can throw some
On
light
the
on that.
exactly, it's on the new testnet, right? The old testnet, we didn't touch for this right now because it's being used for get real testing right now. So we don't want to disrupt the ecosystem on that side. The new testnet is going to become the new testnet, which has a new engine in it. And yeah, I'm constantly pushing Cameron, hey, mainnet, mainnet, mainnet. We want to have it on mainnet. But Cameron says, look, there's so many things that can that we need to check for impact, because when the block time goes up and down, it it is a challenge because a lot of things on a blockchain are tied to the block time, to the time of the block time, right? So the chain runs on the block time. So changing the block time up and down needs quite some careful considerations, and there's a big impact analysis happening right now. So yeah, we make sure this upgrade is bulletproof because it's changing the engine of a driving car to a certain degree, right? So yeah,
Yeah, having said so, I think team is working constantly on this, right? Like making sure that everything is on place. There's a test net, you can go, you can play on that, you can see elastic scaling equip on that. And soon, I would say in 2025, we are very much positive that we will see this on mainnet.
yeah, I'm gonna push for as fast as soon as possible. Yeah, 2025 sounds a bit. No, yeah, let's see. Very cool. Thanks everyone for joining. Thanks everyone for listening. We will do this much more often now. We'll really go into the depths also on the technology we're building, the choices we're making, why we're doing what we're doing. You'll see Kamran much more often from now on, and yeah, we'll just have those conversations, which we have them in private. We have them when we meet and work together. But yeah, like we want to have them in public now and loop all of you in. And yeah, super exciting. Thanks again for tuning in. Check out all the material if you have questions. Right, hit us up on Discord, in the channels, and yeah, see you very soon. Excited to push things now. The next weeks and month gonna be very exciting. Cool, awesome. Thanks a lot.
Thanks a
Bye
lot, Leo.
everyone. Have a good
Thanks a lot.
day. Thanks a lot, Cameron. Ciao, ciao, ciao. Bye, bye.
Ciao, ciao.
Ciao.